Hello and welcome guys to our section. In this video we are going to study the chapter Probability of Class 10 Mathematics. Now in Class 10 Mathematics, probability is a very simple chapter and I hope you understand it easily after watching the video. So why do we study probability? Because it has various applications not only in mathematics but also in various other subjects and fields like physics, chemistry, finance, economics, data science, data analytics and others. So even if you don't take mathematics or statistics for higher studies, you will surely face probability here or there. Hence it is very important to understand the basics of probability in class 10, and that is what we are going to do in this video. So make sure that you watch this video till the end, and if you like it, do hit the thumbs up button, share this video with your friends and subscribe to our channel EduCeption. Without further ado, let's begin. So what is probability? Now we often use the word probability in our daily lives without even realizing it. Say for example, what is the probability of raining today? We say 60% chance है आज rain होगा, 70% chance है आज बारिश होगा. So probability is used over there. Say what is the probability of the winning of India against Australia in this test match? So we use probability over there also. Let me give you another example. Say what is the probability of a wait list ticket getting confirmed? As we say, there is 90% probability of getting confirmed, or there is 80% probability. So a probability has various uses in daily life and it is more or less equal to chance. So we say the same thing, आज इतना chance है बारिश होने का, या this is the chance of India winning against Australia. So same thing more or less. Before understanding the definition of probability and how we calculate probability, there are a few terms that we need to understand. What are those? Let's check them out one by one. First, experiment. An action which results in some well-defined outcomes is called an experiment. So if you do any action that has some well-defined outcomes, then it is called experiment in the field of probability. Let me give you some examples. Say you are tossing a coin. Now when you toss a coin, there are two possible outcomes. You can either get a head or a tail. So tossing of a coin is an experiment. How? It is an action and it results in some well-defined outcomes. So what are the well-defined outcomes? You can either get a head or a tail. So tossing of a coin is an experiment with two possible outcomes, heads and tails. Let me give you another example. Say you are throwing a dice. So when you throw a dice, you can get 6 numbers. Either you can get 1 or 2, 3, 4, 5, 6. You can get one of these numbers. So throwing of a dice is also an experiment which has 6 well-defined outcomes. You can either get 1 or 2 or 3 or 4 or 5 or 6, any one of these 6 numbers. So an action which results in some well-defined outcomes is called an experiment. Simple. Moving on to the next fact, we have random experiment. So what is a random experiment? An experiment is called random if it has more than one possible outcome and it is not possible to predict the outcome in advance. So the examples that I have mentioned already, tossing of a coin and throwing of a dice, both of them are random experiments. Let's check out the definition. An experiment is called random, so both of them are experiments if it has more than one possible outcome. So tossing of a coin has two outcomes, either head or tail. So it has more than one possible outcome and it is not possible to predict the outcome in advance. So before you toss a coin, you cannot say कि हम ये कॉइन टॉस करेंगे और हेड आएगा, या हम ये कॉइन टॉस करेंगे और टेल आएगा. So before you toss a coin, you cannot say whether you will get head or tail. So predicting the outcome is not possible before conducting the experiment, क्योंकि we don't know whether heads will come or tails will come. So tossing of a coin is a random experiment. Same thing with throwing of a dice. There are more than one possible outcomes. There are 1, 2, 3, 4, 5, 6 outcomes, and it is not possible to predict the outcome in advance. So when you throw the dice, you don't know what will come, whether you will get 1 or 3 or 6 or 5 or 4. You don't know that. सिर्फ शकुनी मामा को पता था, बाकी किसी को पता नहीं रहता डाइस थ्रो करने से पहले कि क्या आने वाला है. So throwing of a dice is also a random experiment. Let me give you one other example over here. Say a game of chess. A game of chess has 3 possible well-defined outcomes. What? You can either win or lose or draw. So playing a chess match is also a random experiment. There are more than one possible outcome. There are 3 possible outcomes, and you don't know whether you will win, lose or draw before playing. So playing a game of chess is also a random experiment. So I hope you have understood experiment and random experiment. Very simple concepts. Moving on to the next term, we have sample space. The collection of all possible outcomes of an experiment. This is also very simple. Say we are conducting the experiment of throwing of a dice. So how many outcomes are there? 1, 2, 3, 4, 5, 6. So the number of total outcomes is 6. Hence the sample space of throwing of a dice is 1, 2, 3, 4, 5, 6, all the possible outcomes. We define it like this by curly brackets, and the number of outcomes is 6. Similarly, for throwing of a coin, not throwing of a coin, tossing of a coin, we have 2 possible outcomes, head and tail. So in the experiment of tossing of a coin, the collection of all possible outcomes of that is heads or tails. So the sample space is head and tail, and the number of outcomes is 2. Similarly, for a game of chess also, the sample space is win, lose, draw, and the number of outcomes are 3. Very simple to understand. So the collection of all the possible outcomes of an experiment is called the sample space. Finally, what we have the last term, which is event. What is an event? A subset of the sample space associated with a random experiment. Now it may sound very fancy, but it is not. So first of all, let us understand what a subset of the sample space means. A subset of the sample space means that you take some values from the sample space. So for example, for throwing of a dice, the sample space is 1, 2, 3, 4, 5, 6, all the possible outcomes. So if I take 1 from this, then it is an event where you are getting 1 while throwing a dice. Simple. So getting a 1 is an event. Say for example, what will be the event of getting all the even numbers when you throw a dice? So what are the even numbers? 2, 4 and 6. So when you throw a dice and if you want to get an even number, the event becomes 2, 4 and 6. Simple to understand. And an event can only be a subset of the sample space. से अगर हम एक डाइस थ्रो कर रहे हैं, अब 1 से 6 के बीच में ही आएगा, 7 नहीं आ सकता, ना 0 आ सकता है. तो दैट इज वाई एन इवेंट इज अ सबसेट ऑफ द सैम्पल स्पेस. सो गेटिंग अ 1 is also an event, or getting an even number, say either 2, 4 or 6, is also an event. Simple to understand. So guys, these were the 4 terms that we needed to understand before studying the definition of probability and how to calculate it. So now we'll move on to that. Let's check out the definition of probability and how we calculate it. Probability of an event E is written as P of E and defined as P of E is equal to, that is, probability of the event is equal to number of outcomes in event E divided by total number of possible outcomes. Let's understand this with the help of an example. We have an example over here, which is a dice is thrown once. You have to find the probability of getting an even number. Now, whenever we have to calculate probability in a sum, the first thing that we will do is we will find the total number of possible outcomes. As you can see over here, total number of possible outcomes. So this is the thing that we will find first. In this example, a dice is thrown once. Now, a little while back in this video, I told you that if a dice is thrown once, number of possible outcomes is equal to 6. That means you can either get 1 or 2 or 3 or 4 or 5 or 6. So the total number of outcomes is equal to 6. Let's write it down. We have the outcomes 1, 2, 3, 4, 5 and 6. Therefore, total number of possible outcomes is equal to 6. Simple to understand. Now you have to find the probability of getting an even number. You have to consider getting an even number as the event over here, and as per the definition of probability, P of the event, that means probability of the event, is equal to number of outcomes in event E by total number of possible outcomes. So what we actually have to check is the number of even numbers present in the outcomes. So we have the possible outcomes over here 1, 2, 3, 4, 5 and 6. Over here we have to find the even numbers. So what are the even numbers? Let us write down. Even numbers in the outcome is equal to, what are the even numbers? 2, 4 and 6. Simple. So 2, 4 and 6. Hence the total number of even numbers are 3, 2, 4 and 6. Let me write it down. Therefore, number of even numbers is equal to 3. Done. Now we can simply calculate the probability. So probability of getting an even number is equal to the number of even numbers present, that is 3, divided by the total number of possible outcomes, which is 6. So 3 by 6, which is equal to half. As simple as that. So what we have done is, we first found the total number of possible outcomes, which came out to be 6. Then, as we have to find the probability of getting an even number, we find the even numbers that are present in the outcome. So the even numbers that are present in outcome are 2, 4 and 6. So 2, 4 and 6. Then we finally find the number of even numbers that are present in the outcome. So we have 3, 2, 4 and 6. Hence we calculate the probability. Probability of getting an even number is equal to the number of even numbers in outcome, that is 3, divided by the total outcomes, which is 6, is equal to half. Simple. Now in a similar way we can also calculate the probability of getting an odd number. Let's do that also. So it won't require much space. So odd numbers is equal to, in the outcome what numbers are odd? We have 1, 3 and 5. Simple. So 1, 3, 5. Therefore the number of odd numbers is equal to 3. So therefore number of odd numbers is equal to 3. Easy. Then we calculate the probability of getting an odd number, which is the number of odd numbers present in outcome, that is 3, divided by the total number of outcomes, that is 6. So 3 by 6, which is also half. It is very simple to understand. Once you practice a lot of sums and examples, you won't face any problem in probability. Okay? Now, one very important thing to remember over here is that probability always lies between 0 and 1. Okay? So probability always lies between 0 and 1, and it can never be negative. So if you get the answer as a negative probability, then it is wrong. Or if you get an answer of probability more than 1, then it is wrong. So probability always lies between 0 and 1. So guys, that was all regarding the definition of probability and how we calculate it. Now there are a few other things that we need to understand before beginning with the sums. So we will do that first. Moving on to the next concept, which is a deck of 52 cards. Now we have to understand this concept because many questions in probability are asked from a deck of 52 cards. Also, the origins of probability is associated with gambling. So it is more than fair that we have to study a deck of 52 cards. Now, a deck of 52 cards is used to play various card games like Rummy, Teen Patti, 29, Poker, Bluff, etc. What we have to understand is we have to understand the division of cards among these 52 playing cards. So, the first division among the 52 playing cards is the division of color. There are 26 black cards and 26 red cards. Let me show it to you. Over here I have a deck of 52 cards, as you can see. So we have the red cards and we have the black cards. We need to remember the number of black cards and the number of red cards. So 26 cards are black, that means half are black, and 26 cards are red, so half are red. What is the next division? The next division is the division of suit. There are 4 suits of 13 cards each. So 4 into 13 gives us 52 cards. What are the suits? First we have hearts. Now hearts are red and they are 13. Then we have diamonds. Diamonds are red and they are 13. Then we come to spades. Spades are black and they are 13. And finally we have clubs. Clubs are black and they are 13. So hearts and diamonds are red. Keep that in mind. So 13 plus 13 gives us 26 reds. And spades and clubs are black. So 13 plus 13 gives us 26 blacks. Keep this in your mind. As you can see over here, this is hearts. This diamonds. Then we have the spades, black, and finally the clubs, which are black. So 4 suits of 13 cards each. Easy. Now, cards in each suit. There are 13 cards in each suit. Like I told you, what are they? They are ace, which is also called ikka. Then we have king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. So 13 cards in each suit. Now if I ask you, say, how many 9s are there in a pack of 52 cards? There are 4 9s in a pack of 52 cards. As I told you, each suit contains these cards and there are 4 suits. So every card is present 4 times in a pack of 52 cards. So 9 is present 4 times, but the 9s are different. Let me show it to you. we have this 9 which is the 9 of hearts. Then we have this 9 which is the 9 of diamonds. Then we have this 9 which is the 9 of spades. Then finally we have this 9 which is the 9 of clubs. So in total we have 4 nines, but all the nines are different, and there are 2 red nines and 2 black nines. This is applicable for each and every card. Okay, now we come to the next thing, which is face cards. There are 3 face cards, which are king, queen and jack. And why is that? Because these cards have face on them. As you can see, queen has a face, king has a face and jack has a face. So that is why these cards are called face cards. And 10, 9, 8, 7, 6, 5, 4, 3, 2 are called numbered cards. Okay, easy to understand. Now, how many total face cards are present? Say there are 3 face cards, king, queen and jack. In the entire pack there are 4 kings, 4 queens and 4 jacks. So 4 plus 4 plus 4, 12. So in total there are 12 face cards in the entire pack of 52 cards. Now a deck of 52 cards is also called a pack of 52 cards. Same thing. Okay. So guys, I hope you have understood the concept of a deck of 52 cards. When you solve a lot of sums, this will become more clear. Now we will move on to the next concept. Moving on to the next concept, we have tossing 2 coins together. Now what will happen if we toss 2 coins together? Both the coins will have separate results, or they may have same results also. Head, 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 tail, tail, head or tail, tail. So we have 4 different outcomes. So when 2 coins are tossed together, the outcomes are both the coins may have head, or one coin may have head, the other may have tail. Then one coin may have tail, the other may have head, and both the coins may have tails. So there are 4 outcomes when we toss 2 coins together. Now, an easy way to remember this is by making a board like this, where we have the first coin over here and the second coin over here. Now one coin has 2 outcomes, either head or tail. So for coin 1 we have head and tail, and similarly for coin 2 we have head and tail. So we can either have both the coins having heads, or the first coin having head and the second coin having tail, the first coin having tail and the second coin having head, and finally the first coin having tail and the second coin also having tail. So we get the 4 outcomes. Okay, sums are asked based on this also. So we need to understand that when 2 coins are tossed together, there are 4 outcomes, which are head, 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 tail, tail, head and tail, tail. Easy, simple. Now moving on to the next concept, we have throwing 2 dice together. Now if we throw 2 dice together, then the total number of outcomes are 36. How can that be calculated? Simple, with the box over here. Now say we have 2 dice, dice 1 over here and dice 2 over here. Now when we throw a single dice, the number of outcomes is equal to 6. We can either get 1 or 2 or 3 or 4 or 5 or 6. Same for both the dice. So say for the first dice we get 1 and the second dice also we get 1. For the first dice we get 1, but for the second dice we get 2. For the first dice we get 1, but for the second dice we get 3. For the first dice 1, for the second dice 4. So on and so forth. You can pick any one. Say for example I pick this. For this outcome 3, 4, the first dice will have 3 and the second dice will have 4. So 3, 4. So in total there are 36 outcomes. You will have to remember that. So if you throw 2 dice together, number of outcomes is equal to 36. And questions are asked based on this also. Now guys, we have covered all the concepts that you need to know before beginning with the sums. So now we will begin with some sums. Beginning with the first sum, we have a box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. You have to find the probability that the marble is number 1 red, number 2 white and number 3 red or green. Now I have already told you that whenever we have to find the probability in a sum, the first thing that we find is the total number of possible outcomes. So let's do that over here. For this sum, the random experiment is one marble is taken out of the box at random. So the total number of possible outcomes will be equal to the total number of marbles which are present in the box. So let's do that. So total number of outcomes is equal to the total number of marbles which are present in the box, which is equal to 5 red marbles, so 5, 8 white marbles, so plus 8 and 4 green marbles, so plus 4. We get 8 plus 4, 12, 12 plus 5, 17. So the total number of outcomes is equal to 17. Now let's find the first one. Find the probability that the marble is red. Now to find this, we need to find the total number of red marbles which are present in the box. So number of red marbles. In the question, it is given that a box contains 5 red marbles. So the number of red marbles is equal to 5. Simple. Now we can easily calculate the probability. Therefore, probability of getting a red marble is equal to the number of red marbles which are present in the box, so 5, divided by the total number of outcomes, so 17. So the probability of getting a red marble is equal to 5 by 17. Simple. Moving on to the second subpart, which is find the probability that the marble is white. So over here also we have to find the total number of white marbles that are present in the box. So number of white marbles, and that is equal to 8 white marbles, so 8. Now we can easily calculate the probability. So probability of getting a white marble is equal to the number of white marbles which are present in the box, equal to 8, divided by the number of total outcomes, which is 17. So we get the probability of getting a white marble as 8 by 17. Simple. Moving on to the third subpart. In the third subpart, we have to find the probability that the marble is either red or green. Now, to find the probability that either the marble is red or green, we need to find the total number of red and green balls. So, total number of red and green marbles. This is equal to, we have 5 red marbles, so 5 plus and 4 green marbles, so 4. So in total we have 9 red and green marbles. Now we can easily calculate the probability. Therefore, the probability of getting either a red marble or a green marble is equal to the total number of red and green marbles, which is equal to 9, divided by the total number of outcomes, which is 17. So 9 divided by 17, which is the answer. Simple. Now we will move on to the next sum. Moving on to the second question, we have cards marked with numbers 1, 2, 3, 4 till 20 are well shuffled and a card is drawn at random. You have to find the probability that the number on the card is number 1 a prime number, number 2 divisible by 3, and number 3 a perfect square. In this sum also, the first thing that we will do is we will find the total number of possible outcomes. So let's do that. For this sum, the random experiment is a card is drawn at random. That means the total number of possible outcomes will be equal to the total number of cards that are present. So, total number of outcomes is equal to the total number of cards that are present. So, we have the cards with numbers from 1 to 20. That means 20 cards are present. So, the total number of outcomes is equal to 20. Easy to understand. I have already written the sample space over here. Cards with numbers from 1 till 20. Now, in the first one, we have to find the probability that the number on the card is a prime number. So, prime number. To find this, we have to find all the prime numbers that are present between 1 and 20. So let's do that. We have 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number, 17 is a prime number, and 19 is a prime number. So we get 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 prime numbers from 1 to 20. Therefore, number of prime numbers is equal to 8. 1, 2, 3, 4, 5, 6, 7 and 8. Now we can easily calculate the probability. Let's do that. Therefore, probability of getting a prime number is equal to the number of prime numbers which are present between 1 and 20, that is 8, divided by the total number of outcomes, which is 20. So 8 by 20. So 4 2s are 8, 4 5s are 20. So it is 2 by 5. Simple. Now let's move on to the second subpart, which is find the probability that the number on the card is divisible by 3. So divisible by 3. Let's find out the numbers between 1 to 20 which are divisible by 3. We have 3 itself, then 6, then 9, then 12, then 15 and 18. So the number of numbers which are divisible by 3 are 1, 2, 3, 4, 5 and 6. Therefore, number of numbers divisible by 3 is equal to 1, 2, 3, 4, 5, 6. Now we can easily calculate the probability. Let's do that. Therefore, probability of getting a number divisible by 3. So divisible by 3 is equal to the total number of numbers which are divisible by 3 between 1 to 20, 6, divided by the total number of outcomes, which is 20. So 6 by 20, which will come out to be 3 by 10. Simple. Now let's move on to the third subpart. Subpart 3, a perfect square. A perfect square. So what are the perfect squares between 1 and 20? Let's find out. We have 1 square is equal to 1, 2 square is equal to 40, 3 square is equal to 9, and 4 square is equal to 16. So we have 4 perfect squares between 1 and 20. Therefore, number of perfect squares is equal to 1, 2, 3, 4. Now we can easily calculate the probability. Let's do that. Therefore, the probability of getting a perfect square is equal to the total number of perfect squares present between 1 and 20, which is equal to 4, divided by the total number of outcomes, which is equal to 20. So we have 4 by 20, which will come out to be 1 by 5, which is the answer. Simple. Now we'll move on to the next sum. Moving on to the third question, we have, from a well shuffled deck of 52 cards, a card is drawn at random. You have to find the probability that the card is number 1 a spade, number 2 a red face card, and number 3 a black ace. In this question also, the first thing that we will do is we will find the total number of possible outcomes. Over here, the total number of outcomes will be equal to 52 because we have 52 cards. So, total number of outcomes is equal to 52. Simple. Let's calculate the first subpart. Part 1, a spade. Now, I told you a little while back in this video that there are 13 spades in a deck of 52 cards. So, total number of spades is equal to 13. Simple. Now we can easily calculate the probability. Therefore, the probability of getting a spade is equal to total number of spades present, which is equal to 13, divided by the total number of outcomes, that is the total number of cards, which is equal to 52. So 13 by 52, which is equal to 1 by 4. Simple. Moving on to the next subpart, we have a red face card. Now, I also told you what are face cards. Face cards are kings, queens, and jacks. Now, there are 2 red kings, 2 red queens, and 2 red jacks. Therefore, the total number of red face cards is equal to 6. 2 red kings plus 2 red queens plus 2 red jacks. So 2 plus 2 plus 2 is equal to 6. So total number of red face cards is equal to 6. Therefore, probability of getting a red face card is equal to the total number of red face cards is equal to 6 divided by the total number of cards that are present, that is the total number of outcomes, 52. So 6 by 52. 2 3s are 6, 2 26. So 3 by 26. Simple. Moving on to the third subpart, we have a black ace. Now, I also told you that for each card there are 2 black cards and 2 red cards. So for aces, there are 2 black aces and 2 red aces. Now in a pack of 52 cards, there are in total 4 aces, in which 2 are black aces and 2 are red aces. Therefore, the number of black aces is equal to 2. Simple. Number of black aces is equal to 2. Now we can easily calculate the probability. Therefore, the probability of a black ace is equal to the number of black aces that are present, that is 2 divided by the total number of outcomes, which is 52, which is equal to 1 divided by 26, which is your answer. Now guys, with the end of this sum, we come to an end of the chapter probability. There are many other sums present in your book, in the exercise part also and in the examples part also. Try to solve all of them, and I hope you will understand this chapter more clearly. So guys, I will take your leave now. If you have any doubts, you can email us at eduception01@gmail.com or comment down below. We will surely answer. New videos on Eduception are coming very soon, so stay tuned. Until then, this is Rishi on behalf of Eduception signing off, and guys, take care.